In this video clip, we will talk about complex numbers. We will simply review the complex number, then we will work on the question here. We know previously we said if there is a negative number inside the radical, it does not make sense. And then we need to broaden our number from real number to complex number. It's not really complicated. If we imagine there is a number I, which stands for radical inside is -1, if we assume radical -1 is I, then this one is imaginary unit. We assume there is a number equals that. And then immediately we can get two things. One is I squared is -1. After we introduced this one, then the second result will be radical -9 immediately makes sense, which will be radical +9 times -1, and which will be radical 9 times radical -1, because we have introduced this number. Radical -1 is I. So basically, then this number, radical 9 is 3, radical -1 is I. So then we can deal with all the negative numbers inside the radical sign, and then just by introducing a new imaginary unit, I equals radical -1. So in future, all the radical number choose the square root. You just choose the square root of the real number part and put I behind it. That's it. So again, after introducing this imaginary unit, radical -1 is I, we have two immediate results. One is I squared is -1. This number squared is the number inside the radical sign, which is -1. The second one, we can deal with all the negative number inside the radical sign by doing like this. This number 3i is called imaginary number. Now, if we want to add a real number 4 with imaginary number 3i, can we put together? We cannot really put together. And that's the final answer, which is complex number. This number is also the general form of complex number. 4 is called real part. 3 is called imaginary part. And I is behind the imaginary part 3. So when we do one complex number, 4 plus 3i, with another complex number, -2 plus I, we do is we add 4 and -2 together, which we have a 2, and the 3i plus I. In front of I, there is 1. So 1 times I is still I. So 1 plus 3, you have a 4i. This is like real parts add on real parts, imaginary parts add on imaginary parts. So if we make the relationship or make the connection between a complex number with the previously we learned vector, like 4, like x coordinate of this vector, 3 imaginary part, let's put the y coordinate of this vector. So when you add those two vectors, it it's pretty much look like vector 4, 3 plus vector negative 2, 1. So negative 2 plus 4 is 2. 3 plus 1 is 4. Is 4. So then we have made a good connection. Okay, so addition, subtraction will follow the same pattern. Okay, and then we know if we have made this connection, then vector 3, 4, 3, that will be 1, 2, 3, 4 for x. And the y coordinate is 1, 2, 3. By Pythagorean theorem, the radians will be 5. The length will be 5. So we can rewrite this rectangular form into this form. Radians 5 times cosine theta, we got 4, x coordinate. And then plus imaginary part, I is still here. Then the radians times sine theta will be 3. So this part, this expression will be called what? Will be called polar expression. This part will be called rectangular form. Okay. With those, by the way, here we have a CIS theta. C stands for cosine, and then I stands for imaginary part, and S is the first letter of sine, and theta you put behind it. So sometimes we add a parenthesis. Make it more clear is, let me erase this one. Add a parenthesis here. And then CIS. CIS, again, first letter C, cosine, imaginary I, and then first letter sine. CIS, cis theta. It's pretty much like CSI, crime scene investigation, but here is like CIS, okay? So this one, I said, is just to help you to remember how to remember this cis and then theta, okay? With those things in our mind, we may do is question A. The rectangular form is what? You may want to put right here. And here for this one, you know, it's from 0 looks like to what? To 13, then 14, 15, 16. So here you might do is you input 13 here. Okay, and you hit the enter. Good job. All right. Now we know for this one, you want to choose the first one, remember, is cosine. So you want to choose cosine here or cosine here, not sine. So CIS, not CSI. Okay. So here then you want to put is your radians, which is 13. And then you input 0 and another 0. Wait. 0 here and another 0. You hit enter. Sometimes it does not respond. Let's see. Hit enter here or hit enter here. Let's see if we can. Oh, we should do it this one. So we put 0 here and see if we got 0. Good. And here we input 0, get the keyboard disappear, and then we may check our answer. Okay, great. You can then clear the window. If you did this question wrong, what you can do is, by the way, you want to click on similar question. Then, until you get full credit, you can move on to the next one. So now we are done with question 12. Then we go to 13. 13 apparently is 4i, that's imaginary. Here, this one is on the real axis, it's not. This one is negative. Here we have a positive 4i. This one sounds right. This one is a real number, okay, because it's on the real line. So then we may choose this one, and we may check our answer. Excellent, great. Okay, this one would be easy then. As we said before, we want to type your answer in the form like this, a plus bi. So then you may input 4 plus negative 4 is 0. You do not want to write 0. So basically negative 6 plus 3. So you write negative 3 and then I. And then get the keyboard disappeared and you may check your answer. All right, that's correct. I'll see you next time.